Good morning, guys. Today we're going to be starting a new topic called solving square root equations. Just to say a little bit about square root equations from Algebra 1, equations with square roots or fractional exponents of 1/2 that have variables within the square root symbols are called square root equations. And so you might have seen this in Algebra 1 where if you have a fractional exponent of 1/2, that's another way of writing a square root. We can solve square root equations by raising both sides to the second power. So this is something that we've seen when we were looking for the inverse, right? Whenever we were looking for the inverse of a square root equation, we would raise both sides to the second power. So we're going to be practicing this in this topic, in this chapter. And let me scroll up a little bit so we can see the steps. Okay, so in the examples below, we're going to follow the steps listed here. Step 1, isolate the square root on one side of the equation if necessary. So this just means, let me pick a color here. I've been using orange. So this just means the square root item, the item that's either in the square root, or it can also be inside the power of 1/2. So if you have a situation like this where you have the square root term, or the term that's raised to the power of 1/2, make sure that you have that on one side of the equation. Step 2, if the square root is equal to a negative number, then the equation has no solution. So if it's equal to a negative number, then the equation has no solution. So keep that in mind. And I'm going to use orange when we're talking about square root. So if the square root equation is equal to a negative number, then it has no solution. If the square root is equal to a positive number, or if it's equal to 0, then we go to the steps below, right? Steps 3 and 4. So step 3 says raise each side of the equation to the second power, and then solve the resulting equation. So let's look at example 1. I'm going to zoom in over here. And actually, let me fix it a little bit. Yeah, let's do that much. And then that looks good. Okay. So step 1 is isolate the square root on one side of the equation. So isolate means to put it by itself. So if we look at the square root term, it's this term, right? And so if we notice it's by itself, it's already on one side of the equation. So then the next thing, step 2, check to see check if equal to positive, negative, or 0. So check to see if equal to positive, negative, or 0. So it's equal to a positive for this one. Okay, so that means we can go to step 3. Step 3 says raise each side to the second power. So raise both sides to second power. Okay, so then that's going to look like the following. Okay, so we've raised both sides to the second power. What happens on the left here is that the square root and the square cancel each other out, and so that leaves me with 2x plus 3 equals 9. Okay, and then step 4 says solve the resulting equation. Okay, so now I'm going to solve this. How do I solve for x? Well, I'm going to subtract 3. That gives me 2x. These cancel, equals to 9 minus 3 is 6. And then divide both sides by 2. And x equals 3. All right, so then let's go to example 2. Step 1, isolate the square root. So the square root is this part right here. So how do I get it by itself? There's a 2 in front, right? So how do I get rid of the 2? I would divide both sides by 2. That would cancel the 2 in front there. And so that would leave me with x plus 1 to the 1/2 equals negative 3. Okay, and again, just a side note, from Algebra 1, we should remember that if you have the square root of x, that's the same thing as writing x to the power of 1/2. And so that's just to say that when I have something to the power of 1/2, it's the same thing as having a square root term. So when we said isolate the square root, the term that has the power of 1/2 is the square root term. Okay. Now let's look at step 2. Check if equal to positive, negative, or 0. And it looks like we have the situation where it's the square root term. Pick the color again. The square root term is equal to a negative. So if it's equal to a negative, then we say, according to the rules above, if it's equal to a negative, then we have no solution. Pretty simple, right? All right, let's go to example 3. So let me fix the zoom here. Okay. So step 1. Isolate square root. Isolate the square root. So the square root term is right here. I want to get it by itself, right? That's what isolate means, to get that term by itself. So I need to get rid of the negative 7. So I'm going to add 7 on both sides. Negative 1 plus 7 is 6, equals the square root of x. And then, these cancel. And then I'm just going to rewrite it as the square root of x equals 6. Step 2. Check if equal to positive, negative, or 0. So we have a situation where it's equal to a positive. Okay, so if it's equal to a positive, then step 3 says raise both sides to second power. So that's going to give me the square root of x to the second power, 6 to the second power, then what happens again, what happens on the left side, the square root cancels with the square. That leaves me with x equals 6 times 6, 36. That's it. Step 4, it just says solve the equation, but that's all I would do. All right, example 4. Step 1, isolate square root. So I want to get the square root term by itself here. So the opposite of subtracting 5 is adding 5. These 5s will cancel, leaving me with x over 2 plus 16 inside of the square root equals to 0 plus 5 is 5. And then step 2, check if equal to positive, negative, or 0. And so we have a situation where it's equal to positive. Right, the square root is equal to a positive. Okay, so that means we're going to go to step 3, which means raise both sides to the power of 2. So it's going to look like this, right? So the left side, the square root and the square cancel each other out, leaving me with everything that's inside. Right? And then on the right side, 5 times 5 becomes 25. And then step 4, solve the equation. Okay, so I'm going to subtract 16, get x over 2 equals 9. And then what's the opposite of dividing by 2? Multiplying both sides times 2, so x equals 18. We're done with step 4. Right, one more example. Let's go to example 5. So in this example, this is kind of going back to, remember when we would do graphing and solving on either side. And so we're kind of doing the same thing again here, talking about zeros and roots. And you might remember a problem like this in the review and in the test. But to kind of talk about them again, solutions to square root equations are the zeros of the related square root function. The zeros of a function are the x-intercepts of its graph. The solutions of a square root equation are called roots of the equation. So we're asking us to do two things, right? Graph the square root function and find the zeros. Then find the roots of the related square root equation, which is the following, right? 2 times the square root of x plus, square root of x minus 3 minus 2 equals 0. All right, so let's start by graphing. And we're going to use the rules that we know about graphing from transformations. So we know a couple of things that we know that, for example, we know that the x minus 3, it means that we're going to go to the right 3. The minus 2 means that we're going to go down 2. Let's see, do we remember what the 2 means over here? This was an expansion. Expansion by 2. Okay, so what the expansion means, and so let me make a little table here. So remember we had x and y, and we had, for a square root, it's 0, 0, 1, 1, 4, 2, and 9, 3. And so what the expansion does is it multiplies all the y values times 2. So we would multiply all the y values times 2. So that would give me 0. 1 times 2 is 2. 2 times 2 is 4. And 3 times 2 is 6. So if we graph it, let's say, so again, let's say this is, let me graph the parent function first. So the points in black. So it's 0, 0, 1, 1, 4, 2, and 9, 3. And so what the expansion does is it causes the points to go, well, this one stays there. But over here, instead of being at a y of 1, it's at a y of 2. This would be 4, 4. This one would be at 6. This is what the expansion does. It causes these points to kind of expand upward. And then we're going to move the points to the right 3 and down 2. To the right 3. 1, 2, 3. And down 2. To the right 3. 1, 2, 3. And down 2. To the right 3, 1, 2, 3, and down 2. And we can graph this one, but let's see how far it'll go. So 1, 2, 3, and down 1, 2. Okay, so that would give me awesome. So if I erase all the extra so if I erase all the extra stuff, gives me the following graph. Okay, so that way I can just focus on the blue graph. So this is the graph that I wanted. Now, let me zoom out a little bit just so we can fill in the info. So it's asking, what are the zeros of the function we just graphed? So the function we just graphed is f of x equals 2 square root of x minus 3 minus 2. And so the zeros are the x-intercepts. Actually, I'll use a different color. So the x-intercept happens at x equals 4. Okay. So now let me slide over here and let me see. Maybe I can zoom in. No, I'll leave it like that. That's fine. I'll solve it over there. Okay. So step 1, what we were practicing in the previous examples, is isolate the square root term. So get that term by itself. So I want to get rid of the plus 2, the minus 2, so I'm going to add 2 on both sides. That's going to give me 2 square root of x minus 3 equals 2, because these are going to cancel, right? But I still need to get the square root term by itself. So how do I get rid of the 2 in front of it? What's the opposite of multiplying? Dividing, right? So divide both sides by 2. 2 divided by 2 is 1. 2 divided by 2 is 1. All right. And we know that if it's equal to a positive, like how we were practicing in the previous examples, if the square root is equal to a positive, then I can square both sides, or I can raise both sides to the second power. That leaves me with x minus 3 equals to 1 times 1 is 1. And then I add 3 on both sides, because the next step is to solve the equation. So x equals 4. So the roots of this equation that I solved this is the equation that was originally up here, right? I'm just copying it down here. The roots of this equation is x equals 4. So what's the summary here, right? That the roots and the zeros are the same thing. So I'm just going to make a note here. The roots actually, I already know that they're x-intercepts from the left side, but the solutions of the equation. So there's 4 different names here, right? So we know if we use the word roots, if we use the word solutions, if we use the word zeros, if we use the word x-intercepts, these are all the same. We're talking about the same thing. Just different ways of saying the same thing. All right. Well, this brings us to the end of the notes. Thank you for joining me, and I'll see you guys in class.